So we are going to begin from this place, next hop behavior. You know, whenever a route is advertised from one autonomous system to other autonomous system, the giver of the route will put their address and give. For example, here, if you take this 172.16 network, A, when it gives to B, A is a giver. A will say, I am 10, 10, 10, 3 giving you. So router B learns 172.16.0.0 with the next hop. What is next hop means? The router which is responsible for this network. That is the next hop. The next hop is 10, 10, 10, 3. But when that route is given to an IBGP neighbor, BGP will not put router B's address. The giver will not put its own address. Giver will simply carry the original giver. So when C receives that 172.16.0.0, it will not see this address as the next hop. It will see only this 10, 10, 10. 3. That is what you see here. Read this now, please. Now I want you to read this all 4 lines. Okay, so you understood this last line. It says the next hop advertised by EBGP should be carried into IBGP. Now I want to slightly change this. Let's say I'm forming neighbor using loopback. Router A is 1.1.1.1. Router B is 2.2.2.2. Router C is 3.3.3.3. So we are using this time what address? Loopback interface address to form neighbor. Now, it will not be 10, 10, 10, 3. Instead, the address that you use to do form neighbor with the other autonomous system. You understood? Please understand this. The next hop address will be the address that you use to identify the next autonomous system. Not the address that you use to reach the next autonomous system. To reach the next autonomous system, you may be going to this gateway, but that is not going to be your next hop. Because the giver of this network is this neighbor, isn't it? This is how you identify the neighbor. This is the address with which B is identifying the neighbor. So when you use loopback and address as a neighbor address, B will say, I learned 172.16.0.0 from my neighbor, who is my next hop, 1.1.1.1. Not 10, 10, 10, 3. Understand this. It's not explained here. They failed to explain. It is, I don't know, it's very important. They failed to explain. I'm explaining it. Now let us say B and C is forming neighbor using loopback. Now when C receives that 172.16.0.0, what will be the next hop? Tell me. Exactly. Next hop will be 1.1.1.1. But the poor router C, why I'm calling it as poor? Because this don't know where is 1.1.1.1. Why? Because it is in some other autonomous systems, Lubeck. So even though BGP is learning from legitimate neighbor router B, who gave this one? It is given by the legitimate neighbor router B, isn't it? Even though a legitimate, well verified TCP protocol is BGP, well verified neighbor is giving this, it cannot use it. Why? B is giving a network next hop address which I don't know. I do not know where is Kerala. Then how will I go to Kodamangalam? 172.16.0.0 is Kodamangalam in Kerala. Kerala is somewhere I don't know. I am from Africa. I don't know where is Kerala. I am an African. I don't know where is Kerala. I don't know whether Kerala is a continent or a country or a state or a village or a town. I do not know. Arinjuda. So, what is the solution? We need to go to B and tell B, put your own address because the poor C don't know. Because he don't know, it says it is valid, but not the best. Why it is not the best? Because the next hop is unreachable. If C pings 1.1.1.1, it don't know where the network is. It cannot ping, isn't it? Because it cannot ping, it cannot use it. So it will say valid, but it won't put it in the routing table because it is not best. So to make it best, what we have to do is we should ask router B, we need to say router B, whenever you speak to this 3333, whenever you send anything to 3.3.3.3, put your own address as the next hop. That is the command next hop self. Yeah? Where do you configure this? Will you configure this on C? Will you configure this on C or A or B? Where will you configure this command? Next hop self. No, I'm asking you a question. Where will you configure B or C or A? Where will you configure this next hop self command? What is this, sir? No, no, no. See, B is learning with the next hop, which is reachable. Yes or no? Is this not reachable for B? If it is not reachable, how it formed a neighbor? You already wrote static. You remember you did static route, UBGP multi-hop, all those things you did. So it is already reaching. 1.1.1.1 is reaching. Now when B gives this route to C, I want that to use 2.2.2.2 as the next hop instead of carrying 1.1.1.1. So I need to go to only B router and say, whenever you talk to C, what is C? Whenever you speak to the network neighbor 3.3.3.3, put your own next address as the next hop. So when C receives 17, So after saying next of self, what will be the address that C will receive for the network 172.16.0.0? What will be the next hop? Exactly, that's all, sir. You learned it. Now I want you to go through this example. Okay, I'll also tell once. Router A is advertising this network with its own address because that is the address with which you formed a neighbor. I told you the neighbor address would be given, correct? Is my voice clear or making some noise or anything in the background? Okay, and because you have said 3333 neighbor, which is router C, you are configuring this on router B saying whenever I send any update to router 3, I need to put my own self address. What is the self address? 2222. So the next hop is changed. Now on C, you no need to say this because by default, when C gives to other autonomous system, it will put the address which is used to form neighbor, which is 192.168.2.1. You understood, sir? Now the challenging part is coming here. I want you to give 1, 2, 3, 4, 5 times reading, and then I'll come and explain it. I forgot to record for some time. So router B understands that A, C, and B, we are all in same subnet. So when it receives an update from C, 10, 10, 10, 2, yes or no? This will be received with 10, 10, 10, 2. Even this will be received as 10, 10, 10, 2, isn't it? These two. So B understands that I'm receiving from 10, 10, 10, 2, and A is in 10, 10, 10, 3, same subnet. So instead of me giving my own address, I'll give 10, 10, 10, 2. Instead of 10, 10, 10, 1, it gives, wait, please, 10, 10, 10, 2. Why it is giving like this? The neighbor is not formed with 10, 10, 10, 2. These two used this address to form neighbor. Why it is giving 10, 10, 10, 2? If it gives 10, 10, 10, 1, then packet will come here and then go here. It will be unwanted hop. Because it's a layer 2 switch, it's not layer 3, it's not different network. Going like this for this network and this network is the best. That is why it is called an efficient protocol. It is clever. But for 10 or 20 network, it gives its own address with which you form neighbor. Because this is the best entry. But for this network and this network, this is the best entry. This is see, we do have layer 2 connection. There's one switch. A is connected to switch, C is connected to switch, B is connected to switch. There is no connection directly to B nor C. They are connected in one single LAN. You can also say it is directly connected because it's same LAN. Is this clearly understood, sir? I think we'll